We're moving on to talk about polynomials. The objective for this lesson is that we will be able to classify polynomials and also work with the graphs of polynomials. So let's look at some vocabulary involved with polynomials. First of all, polynomial means many terms. So what we have with polynomials is that the poly means many, and so we're going to have many term polynomials. We're used to working with binomials and trinomials. So a monomial is where you have one term. And what that means is if you have, for instance, like a 3x squared, a binomial, the word bi meaning two, is two terms. An example of that would be, for instance, 4/5 x plus 7. Right? And then trinomial means three terms, which we did a lot in the last chapter. For instance, x squared plus 8x plus 7 is a trinomial. It's got three terms to it. Now, one thing you have to make sure you recognize with a polynomial, and you have to make sure that when we're classifying it, if it's a polynomial or not, is you have to make sure you don't have any variables in a denominator, in the bottom of a fraction, or under a square root. So no variable in a denominator or in a radicand, which again means underneath a square root. Underneath a radical. So no variable in a denominator or under a square root. So that will help us when we're classifying, okay? When we're working with this, we'll be able to tell, is it a polynomial or not? And if you see a variable in either of those cases, it's not a polynomial. Now, let's look at this monomial and just do a little bit of talking about the vocabulary. The coefficient is the number in front of the variable. So when we look at this term here, this number 4 is the coefficient. Remember that the x is the variable and the 10 is the exponent. So those are some terms we're going to use very frequently. You really have to become familiar with the word coefficient because we're going to use that a lot when classifying these. All right, so when talking about terms in a polynomial, like here's a polynomial, there's no variable in a denominator or under a square root. When you're talking about terms, we're looking at the polynomial where it's separated by plus or minuses. So terms are separated by a plus or a minus. So if you look at this polynomial here, we have 1, 2, 3, 4, 5 terms. And notice we have coefficients, like 17 is the coefficient of this term, 18 is the coefficient of this term, and so on. But when talking about the number of terms, 5 terms because it's separated by plus or minuses. Back to these here, monomial, binomial, trinomial, those were classifications by the number of terms. 3 terms because they're separated by pluses. We have 1, 2, 3 terms, 2 terms here, and just 1 term there because there's no pluses or minuses. So we can classify according to how many terms there are. Now, if it's larger than a monomial, binomial, or trinomial, you just label it by the number of terms. Like this, we would say a 5-term polynomial. Okay, so we'll use monomial, binomial, and trinomial for those, and otherwise we just give the number of terms that it is. Now, if we have, on the other case, we're talking about the word powers. Powers is a term that we'll often use when we're talking about exponents. So we'll be using those interchangeably. If you hear the word to what power is it, it means to what exponent are we listing. All right, now let's talk about descending powers. So this is like descending exponents for it. Now when we look at this, descending powers, you want to put the largest exponents first. So this would be if we have one single variable, you're going to just list it with the largest exponent number first, and then go down from there. So we do want to make sure, and I'm going to emphasize this, you want to put them in order. So many of the things we talk about with this is referring to when they are in order. So make sure you put it in descending powers order first. Then when we talk about the degree of it, the degree is if it's a single variable, the degree is the largest exponent in the polynomial. This is when we have just one variable, like all of the variables are x's or all the variables are y's. Now, just as a side note, the degree will be if you have more than one variable, you add the exponents on the variables. Okay, so more than one variable, we'll put a little note here. Add the exponents on the variables in each term. We'll get to that later, but for now, if you're dealing with just one single variable, it's just the largest exponents. All right, so what we want to do here for degree of one variable function, so let's say that x is our variable, okay? When we want, let's do an example of degree here. So an example of this is if we had 14x to the fifth plus 17x to the third. What is the largest exponent on one of the variables? The degree would equal 5. Because that 5 is the largest exponent we have on that variable because it's a single variable. All right, now let's classify according to the degree. If it's just one variable in it, like this here, what we'll say is if you have a degree of 1, then it's called linear. If it's degree of 2, which we did a lot last chapter, we did degree of 2 quadratics. We had x squareds in the problem. Cubics are a degree of 3. If it's above a cubic, we tend to just say, for instance, a 5th degree polynomial for that. All right, so let's do an example of that. So if we had, for instance, 17x to the third power, this is a cubic because it's a degree 3. If you had 7x squared, that would be a quadratic. Okay, so let's talk about now just looking at a polynomial. We want to define what leading coefficient. We're going to use that word coefficient a lot in this chapter. So leading coefficient is when you line them all up as we're supposed to. So you gotta put them in order. It's the number in front of the polynomial. The first coefficient in an ordered polynomial. Okay, so we look at this polynomial here. The first step you've got to do is put it into descending powers order. So let's look at this one. You look at the powers here, and I look and say, well, that's the largest one, so I want to put that one first. So I'm going to put negative 10 x to the fourth. What comes next? Well, this one's next because it's got the next largest power to it. The 48, the quadratic term, that comes next because it has an x squared. The linear term, the one with just an x on it, that will come next. And then I look for one that doesn't have any variable on it, the constant, and I put that last. So I took this 1, 2, 3, 4, fifth. I take this 5-term polynomial, 5-term polynomial. It's now also, notice the largest degree, it's a 4th degree, because that's the largest degree in the polynomial. And then I look at it and say, what is the leading coefficient for this? And the leading coefficient would be the number in the very front. So the first number in it, the first coefficient, or in this case, the first number. Okay, and the first number here, so leading coefficient is going to be that leading number, which is negative 10. Okay, so negative 10 is my leading coefficient. So a lot of vocabulary. The major ideas here are to understand what coefficients are, to know what degree is for each of these, and also to know how many terms you have in the polynomial and how to classify it. Okay, so we would say 5th degree polynomial, 5-term polynomial, 4th degree leading coefficient of negative 10. That would be one way to classify this polynomial here.